Okay, I think now it's good time to make some update video of this new motor control project. So this is the new version of my previous controller, and I have been now doing the schematic for this, and I have started to also making the layout design. So I can show. So here I have been doing this like hierarchy sheets, and I can briefly show how I have like made them. Well, we can actually move this a little bit here. We can draw the box for this. And then there is the debugging part. Well, I can make some box for those later. But those are the components, and I might still add some components, but now everything is mainly there. And this is the new layout design. So the new PCB would be around 80 millimeters and 80 times 80 millimeters. And on this design I'm using different kind like current measurement system and layouting. I can show from here. So basically here will be the 3 phase currents, and the power input will be coming somewhere here. It's not like locked in, but it will be somewhere here. And the top part will be like the high power part. So idea is that the current will be flowing in this area, and then the microcontroller and analog circuits are like here. So they should have better like cleaner area where they are working. And then this board will be 6 layers. I can show like I have been making this kind of like symmetrical thing, so I have decided that every face will have this 70 millimeter like area, and I have been using this user drawings as like boxes, so it's easier to like make this kind of like symmetrical design. Example here, if we check, all the shunt resistors are 70 millimeters apart, and then like I have been also making this kind of lines here, so it will be then easier like if we add this line here. So this is like the user drawing, so it will help that when I'm placing our parts that it will be easier to line them like correctly. And then like on this power section I'm using a lot of this kind of like polygons. So we can check that this polygon starts from here, and all the this face states they are like symmetrical, so we can just Control C and Control V. We can copy this, we can place it here, and we can check like should be exactly at the same spot now. And the only thing, so this is using the old net, so if we build it, it will look like this. But only thing we have to do is just change the correct net from here, and now we have that polygon here, and it will connect to these MOSFETs. Yeah, about this PCB I think there is not other updates currently, but I can show the this new tool I have been working on. So it's hosted on this website here, and it is working on this my previous motor control. So from here we can connect it, and when we connect we can see that this web app will send this kind command to the microcontroller, and then it will answer these different parameters. So I will be adding other parameters here, but these are currently the ones I have been using for like developing, but there can be much more parameters. So then we can like select something here, like what we want to log, like now we can press this and then we just start logging, and it will start like at 20 kilohertz. It will start logging these parameters, and then we can even export CSV. So we can like start logging that, and we can enable a driver, and we can see that something is changing, and we can start motor. So this is actually the this HFI signal what it is creating here. So we can stop that and check what was happening there. So currently on this design I'm using rotating HFI. So it will inject this kind of signal here. Like on this example it was injecting like 200 milliamps peak to peak signal there for like detecting the motor position. So we can have that there, and then from here we can like select 4 amps, and now the actual motor is spinning, and now I'm like stopping it with my hand and turning it. So it's currently using this salience tracking without any sensors. And for the next version, the idea is that I can reduce this HFI measurement signal a lot. Like now it's here, we can see. And for that, like reducing it, then it should be like totally silent HFI. Currently it's making some noise because it is injecting that amps, but next version should be much more like accurate and need less amperes. But then there is some other stuff also. I have been adding this, and at some point firmware update should be also possible from here. And then I can keep that going, and then with the disable driver it will disable driving. Yeah.